Good morning, sixth graders. I hope everyone had a fantastic weekend. So today we're going to continue our unit, which is on finding area, and we're going to find area of polygons today. Now this is very similar to finding area of special quadrilaterals, which we were doing at the end of last week. The only thing that's different is that quadrilaterals only have 4 sides. Polygons don't always have to have 4 sides, but we're still doing the exact same thing where we're breaking up a shape into smaller shapes that we can find the area of, and then we're just adding all those areas together. So really quick, before we begin, I do want to just review the area of a rectangle, the area of a parallelogram, and the area of a triangle. So if we were just given any sort of rectangle, to find the area of this, what would it be to find the area of a rectangle? Well, a rectangle will be length times width. Now, to find the area of a parallelogram, okay, our area would be base times height. Remember, we cannot use that diagonal dimension. It doesn't give it anything. So it has to be the base, and then the height could either be represented like that, or even it could be represented like that on the side too. All right, and lastly, area of any type of triangle. No matter what type of triangle, as long as it has 3 sides, the area is going to be what? Well, it's going to be base times height divided by 2. And again, you may see it like this, half base times height. That's another way you can see the formula for a triangle. So these area formulas are not going to go away because we are going to be using them today as well. All right, so let's do an example. All right, so let's look at, and right now I am on page 677 in your workbook. I'm taking this example from it, so you can totally look in your workbook, 677. All right. All right, so we're given this shape. Obviously, it's not a quadrilateral because it has more than 4 sides. It has 1, 2, 3, 4, 5, 6 sides. So it's a polygon, all right? And we're given that this dimension right here is 15 inches. This dimension right here is 10 inches. Up top here is 5 inches. And then right here is 22 inches. All right, so we are given all the information we need to find the area of this shape. So look at this shape and tell me, how do you think we can split this shape up so that we can find the area, or find the area of this shape? Well, there's 2 ways you could do it. Now you might have thought this way, and that's totally fine. You can split it up like that, but some people also might have thought this way. It does not matter which way you break it up, you'll still get the same exact answer. All right, so let's look at this way, right here. Okay, so if I break it up like this, I have shape A and I have shape B. And this topic may seem very familiar to you because we did something like this in 5th grade with volume. And it's kind of the same thing. We're breaking up the shape and then we're trying to find the area of each side. But instead, last year, as 5th graders, we were finding volume. All right, so shape A, it's a rectangle. I see a length of 5, a width of 22. We're gonna multiply 22 times 5. And we end up getting 5 times 2 is 10. 5 times 2 is 10 plus 1 is 11. So we end up getting 110 inches, and remember, squared. So A is 110 inches squared. B is 15 times 10. Well, I can do that in my head. 15 times 10 is 150 inches squared. So to find the total area, 150 plus 110 would give me 260 inches squared as my total area. All right, and that's all we're doing. We're just breaking up the shape into different shapes that we can find the area of. All right, now let's say that we didn't break it up like that. Let's say instead, okay, you were the person that broke it up the other way. Keep in mind, we got 260. All right, you broke it up like this, and that is totally fine. But if you broke it up like this, you might need to do some subtraction. All right, so let's look at this tiny little rectangle up here. Okay, you have 5 inches, but then you need to find this dimension. All right, now if you have to find this dimension, 22 is the whole thing, so you're not going to use 22. What are you going to do to find this tiny dimension? Well, if 22 is the whole thing, I'm going to look at my other heights. I see that 10 is over here. So if 10's here, then that means 10 is here. So then what we can do is we can do 22 minus this 10, and it will give us what the remaining is. So 22 minus 10 is 12 inches. So to find this tiny area, we would do 12 times 5, and we would end up getting 60 inches squared. And now again, let's look at this shape, okay? I see that this is 10, so I'm gonna use 10, but then I see that 15 is only here. Okay, I wanna go the whole entire way. So what do you think I'm going to do to find the whole entire length? Well, if 15 is just from here to here, 5 is from here to here, which means that this is also 5. So I can do 5 plus 15, and I end up getting 20 inches. And now 20 times 10 is 200 inches squared. 200 inches squared for the bottom, plus 60 is again the same thing that we got before, 260 inches squared. So depending on how you break up a shape, you may need to do some subtraction, just like we did for special quadrilaterals, all right? So what I'm going to do real quick, I'm going to give you one more example, and I want you to try it on your own before we go over it. All right, let's see. All right, let's see if I can draw this. All right, so we're given this shape. It has 1, 2, 3, 4, 5, 6. Do you remember what a shape with 6 sides is called? Well, it's called a hexagon. All right, so we are given a hexagon, and we're actually given some dimensions. So this top line is 4 meters. All right, and then they give us also that the height is 6 meters. They draw a line here as well. And then they give us this dimension right here is 2 meters, and this dimension right here is 2 meters. And then they also give us this box, which tells us that if this is a triangle, we know this has to be the height and this is the base. So they're giving us that information, all right? So look at this shape right now. If you want to draw this on a separate piece of paper, you totally can, but solve this. See how you want to break up this shape? Personally, I would break it up rectangle, triangle, triangle, all right? And see what you get as the total area of this polygon. All right, so let's solve this. So I like writing the letters that each section is. So I'm gonna call this A, I'll call this B, I'll call this C. So A is a triangle, okay? And I can see, again, if you like wanna turn it this way, the base of the triangle is 6, the height is 2, okay? So base times height, 6 times 2, but then I have to, because it's a triangle, divide by 2. So 6 times 2 is 12. 12 divided by 2 is 6 meters squared as my area. Now I'm noticing that this triangle is identical to this triangle. So yes, I could do base times height divided by 2 here, but if this is 6 meters, then this has to also be 6 meters squared, okay? And I'm just doing that because it has the same base and the same height. If it didn't, I would still have to solve it on its own. All right, so now we're just left with the rectangle, 4 times 6, which is 24 meters squared. And now all we're doing is doing 6 plus 24 plus 6. So 6 plus 6 is 12. 24 plus 12, we get 36 meters squared as our total area. All right, so that's all this topic is just breaking up a polygon into easy shapes that we can find the area of. Very similar to what we have been doing. All right, have a good day.